Humans are the only species on Earth that routinely needs help during childbirth. Every human culture across history has had midwives or birth attendants of some kind. Gorillas give birth alone. Chimps do the same. Elephants, dolphins, whales, all unassisted. But leave a human woman completely alone during labor, and the risk of something going badly wrong is not small. In pre-industrial England, maternal mortality ran at about 10 deaths per 1,000 births. Across multiple pregnancies, the lifetime risk for a married woman was roughly 1 in 18. And that's with some basic care available. In deeper prehistory, it was likely worse. Our closest relative, the chimpanzee, gives birth to infants weighing about 3.3% of the mother's body mass. A human baby weighs about 6%, nearly double. The baby is also navigating a birth canal that twists and narrows, requiring the infant to rotate its head and shoulders at least twice just to get out. No other primate birth involves this rotational complexity. In chimps and gorillas, the baby exits facing toward the mother, so she can reach down and guide it. In humans, the baby exits facing away. The mother can't safely guide the head without bending the spine backward. She needs someone else there. So why didn't evolution just fix this with wider hips? The classic answer is called the obstetric dilemma, coined by anthropologist Sherwood Washburn in 1960. Around 7 million years ago, our ancestors started walking upright. Bipedalism reshaped the pelvis. It needed to support organs, balance body weight over 2 legs, and allow efficient walking. This narrowed the birth canal. Then around 2 million years ago, the genus Homo started developing much larger brains. The infant skull got bigger. The birth canal stayed narrow. Evolution's compromise was to birth the baby earlier, before the skull outgrew the exit. This is why human newborns are so helpless. A foal stands within hours of birth. A chimp infant grips its mother immediately. A human newborn can't hold its own head up for months. This explanation dominated for 60 years. It's still what most people mean when they discuss this topic, but it has real problems. The first problem is the assumption about locomotion. Washburn assumed wider hips would make women biomechanically worse walkers. When researchers actually tested this with real biomechanics data, they found no meaningful difference. Wider hips don't make you a worse biped, so that constraint doesn't hold up cleanly. The second challenge came from a completely different direction. In 2012, anthropologist Holly Dunsworth proposed what's called the energetics of gestation hypothesis. By around 9 months, the growing fetus is consuming energy at a rate the mother's metabolism simply can't sustain. She's already running near her physiological ceiling. The baby leaves not because it won't fit, but because it's too metabolically expensive to keep inside. Under this model, the helplessness of newborns is a consequence of early eviction driven by energy limits, not a design solution to a pelvic size problem. There's a third constraint that rarely gets discussed. Standing upright shifted the weight of all internal organs onto the pelvic floor, a hammock of muscle at the base of the pelvis. A wider pelvis weakens that floor. If the pelvic outlet expands too much, the pelvic floor can't adequately support the organs, especially during pregnancy. So there's a structural reason, entirely separate from walking efficiency, that keeps the birth canal narrow. Evolution is balancing 3 competing pressures simultaneously, not 2. And in 2024, a study using 3D birth simulations found that chimpanzee births also involve a tight fit between the fetal skull and the birth canal, nearly as tight as in humans. The obstetric dilemma didn't suddenly appear with bipedalism or big brains. It evolved gradually across primate evolution, with humans at the extreme end of a spectrum rather than as a unique outlier. What makes human birth distinctly dangerous is 3 things stacking on top of each other. First, absolute brain size. A human newborn's brain weighs roughly 366 grams at birth. A chimp newborn's brain weighs about 136 grams, nearly 3 times larger, despite humans being born at only about 27% of adult brain size compared to the chimp's 36 to 40%. Second, infant size relative to the mother. Human babies are nearly double the proportional weight of chimp babies relative to maternal body mass, a larger object through a constrained space. Third, the rotational complexity. The human birth canal inlet is wider side to side, the outlet wider front to back, so the infant must enter facing sideways, rotate mid-canal, and exit facing downward. Nothing else in primate birth comes close to this. All of this created a social consequence that doesn't get enough attention. If you need help to birth a baby safely, you need to be embedded in a group of people willing to help. The demand for birth attendants may have been one of the early pressures selecting for tighter social bonds and cooperative relationships. Some researchers argue this predates large brains entirely, that even earlier bipedal ancestors like Australopithecus, with relatively small brains, already needed cooperative care simply because bipedalism had begun reshaping the pelvis. The brain that made us the most cognitively complex animal on Earth required a birth process so dangerous it couldn't reliably be completed alone. We needed each other to exist at all.